Hello Science 10s! This video is about motion and average speed. Look at this guy's face. You have to be going pretty fast for you to look like that. So let's see what happened to this Top Gear fella. The first thing we want to know about is motion. And motion is just any change in length or direction from the starting point. For example, we can imagine ourselves in the summertime floating down this lazy river, and that would be motion. We're moving. Now, uniform motion is a little bit different. This means that an object is traveling at a constant speed in a straight line. This doesn't happen that often because we don't have roads that go on for 100 kilometers perfectly straight, where you never have to speed up or slow down or change direction. So we don't see this very often. Here's some examples and non-examples of uniform motion. So tell me, if you are walking in a straight line at a constant speed, is this uniform motion or not? Yes, it is. I'm sure you got that one. How about if you're walking around a track and then you fall over like a pigeon that's lying there and then you get up again? What would this be? This is not uniform motion. The next one, if you're speeding up when you bike down a hill, what will happen here? Do you have uniform motion or not? This is not. Our last example, if you have a maglev train, which are super fast trains that can go on magnets, traveling on parallel tracks, is this uniform motion? It is. Now let's talk about average speed. Because uniform motion is so difficult to maintain over a long period of time, we can use an average. To do this, we take this equation, we do need some math and physics, where we have the average speed, which is equal to the total distance that you've traveled over the time that has elapsed. Our symbols look like this. We have average speed, which is a small v, has to be small, we can't have a large v, that means something different, and our units are meters per second. Our distance is a small d, and the units are in meters, and time is a small t in seconds. Now all of these units may be something else in the question, but you have to convert them to these general units, meters per second, meters and seconds, for the equation. Now remember when we talked about vectors and scalar quantities? When we talk about velocity, velocity is a vector quantity, which means we need both magnitude, the size of the motion, as well as the direction. Velocity has to have a direction involved. So the small v will have an arrow over it like we saw in displacement. An example of this would be 3 meters per second east. Here's an example. We have a clown. We all love clowns, and he walks 10 meters east from a stop sign in 5 seconds. What is his average speed, average velocity? What do I know? I know the distance, the displacement should have an arrow, which is 10 meters east. I also notice that there's 3 significant digits in the 10.0 meters. Remember that way back in chemistry with significant digits? We need that again. My time is 5 seconds, 5.00, again another 3 significant digits. So looking at that, I know my answer will have to be in 3 significant digits because that's the lowest amount. I don't know what velocity is. This is what I'm going to find out. Find my formula, which is v equals d over t, and then I solve it. So I put in my numbers, divide, and I get 2.00 meters per second east. I must include the direction for velocity. I also have to have 3 significant digits, so it has to be 2.00. So many rules in physics. Now sometimes it's not so beautiful to get just the velocity, and they may want you to find distance or time, so we have to rearrange the equation. Now I know you've been doing this all in junior high, how to rearrange these equations. So you have to remember the velocity equals distance over time, and then you can rearrange. If I want distance instead of velocity, I will take the t, which is at the bottom here, and do the opposite. The opposite of being divided is multiplication, so I multiply by both sides, and I end up with d equals v times t. If I want time instead, then I'm going to have to get rid of the velocity. I'm going to divide both sides by v and end up with the equation t equals d over v. So you can remember one of the equations and then use your algebra skills to rearrange for the correct variable. Oh, more clowns. Now they're riding a train. Okay, so they are traveling not so fast at 6.9 meters per second west for 4 seconds. We have to calculate the distance traveled by this train. So what do I know? I always write down what I know first so that I have a point to start at. I know the velocity, 6.9 meters per second west, and the time of 4.0 seconds. Both of these have two significant digits, so I'm going to have that in my answer. I have to find the distance. Well, the equation I know is v equals d over t, so I'm going to have to rearrange that equation so it looks like d equals. The d equals equation is the velocity times time. Then I'm going to solve it. I put in my numbers, 6.9 meters per second, multiplied by the 4 seconds, and I get 27.60 meters. Because I can only have two significant digits, I have to round. I look at the 7, beside it is the 6, so I'm going to round up to 28 meters west. I have my two significant digits. Now clowns have been walking, they've been on trains, what else could they possibly do? They can go in an airplane! So now he's in a Concorde airplane, which is a super fast airplane. It can fly at the average of 694 meters per second going southwest, perhaps down to Arizona. Calculate how long it would take the clown to fly around the world. Oh, he's not going to Arizona, he's going around the world, which is about 4 times 10 to the 7 meters. Oh my goodness, do we remember scientific notation? This means a very big number, right? That 7 means that you're going to move this decimal place over 7 times. So it's a huge number, but the world's a pretty big place, so that makes sense. So what do I know? I know my velocity, has my direction there, and I have 3 significant digits in the velocity. Distance is going to be 4.00 times 10 to the 7 meters. This one also has 3 significant digits because we just look at these numbers, not these numbers. So these zeros count, but remember if it was before the decimal to the left side of the decimal, they would not count. Now I need time. I have to rearrange that equation again. Luckily, I'm very good at math, so I can rearrange it to make it look like t equals d over v. Now I'm going to solve it. So I'm going to do it the exact same way every time so that I have a pattern to follow if I'm confused. So I put in my numbers, my distance divided by my velocity, put it into my calculator. If you don't know how to use your calculator, do the 10 to the 7. You missed that part in chemistry. Come and talk to me tomorrow. Now I get a huge long number, all these seconds, so I'm going to have to use scientific notation because I can only have 3 significant digits. So I have to move this decimal point over 1, 2, 3, 4 points because my number has to be between a 1 and a 10. So that is where my 10 to the 4 comes from. And then I have my 3 digits. 6 is the last digit. I look to the side as a 3, so I can leave the 6 like that. So there is my answer. Now you can go back through the video if you need to write down some of those worked examples and your notes, and we can work on our assignments tomorrow. I don't think there's any more clowns in them though.